one more thing. Okay, so now let's look at how we can begin to graphically show the height elevation for this. This can be another thing that you could possibly show for your presentation of this project. So let's go ahead and just get rid of all of this. So we could use like the basic idea of creating the elevation colors for this. So we have our B rep. We will convert it to a mesh. Turn this. So we have our mesh. And essentially what we're going to do is say wherever the Z location is for these points that that'll indicate the color value. So we have our mesh here. We'll deconstruct it so we can see where all these points are on this. Let's actually do it for just this surface again. So instead of the whole thing, let's just do it for this part. So I'll turn this off. Let's turn this off. So there's our mesh surface. We see that we have our vertices are our points. So we go over to vector or the point and deconstruct these points. So instead of them having all three values or three axes, so X, Y, and Z, we're only interested in the Z value, where it's actually located in relation to the surface. So with that Z value, let's drag this down a little. Let's actually construct this mesh again. And then we're going to use this to kind of create our colors for this mesh. And the reason to use like a mesh is because then again, you can bake that and then you can actually keep that color, which is nice. So the Z values, so we'll go to math, min and max values. So we can see that we have a depth of negative 6.7 and a height of 6.9. We'll deconstruct these values. Now we'll go to our parameters to choose the color gradient. We'll just treat the start or that low value. So now we have, there's negative 6.7, here's 6.9. Those are just these extents. And then we need to know all those values. So all these Z values. So we know how they kind of fit in everything. We can change our preset to whatever color we want. We'll just do a grayscale for this. And I'll drag it into there. So now, probably doesn't work or look so good having your high points black and then your low points white. You could simply just reverse where these go. So now they crisscross, or you could just alternate these to go back to what it looked like. But here, at least you can start to kind of play around with the colors. If you want, you can even introduce other colors you want. Again, this can be kind of something more abstract. So maybe you want those high points to have a very distinct white peak to them. You can create another color. Come on. Maybe that thing fills in. Oops. Let's keep that one there. Maybe it's more. Maybe this is supposed to symbolize that that's where like the water's flowing through in this case. If you want, you can always kind of create another color. And I'll make this one also black. I did the wrong one. So that way it's just a little more. So you can create something kind of interesting like that. So, I mean, that's a pretty kind of basic way of showing those colors in a very smooth way, but you also could take another approach where you could actually divide it into an interesting grid. And this approach, I use it for a lot of techniques. I'll just do it to show color. So, and if we have time, I can show you where you can start to take it when we get into like the design phase. So I'm going to go, so everyone get that technique of how you can add the color gradient to the height field? I'm gonna, again, go back to this, or let's not do this one. So we're gonna look at ways in which we can manipulate this so it's less of this kind of nice, fluid, solid surface. So if we want to divide it into essentially a grid. So I'm going to go to Surface, Utility, IsoTrim. This is the component that starts to divide it into a grid. It's asking for a domain. So that's just how you are dividing these cells. So I'll go to Math Domain. I'm going to go all the way to the bottom where it's Divide Domain. This I value is, in this case, our surface. So this is one of the times where it doesn't always follow along, but that I value is actually your surface. I'm going to drag this into here now. And so now you can see that it has this kind of interesting cell division. Let's turn this off. So unfortunately, we kind of lost that trim, but oh well. We could always trim this. So I'm going to, like right now, you just divide it by certain increments. In this case, maybe I want these cells to be a certain size. So if I go to Surface to find the dimensions, so I can see that it's 244 by 112. If I want these to be spaced maybe every 5 feet or so, I can do a little math operation here. So I'm going to take these values, divide each of them by, let's do 5 for now. So every 5 feet. And these will now become those guys. So now our grid's a little more dense. If you want them to be even smaller, you can really start to shrink it down. And so we can use the same technique where we did before to create this color gradient. So I'm going to essentially copy all of this. I'm going to do the same thing, or I'm going to find the area of each one of these subsurfaces. So now there's a point that's going to be associated with every single one of those. And we're going to do the same thing where each one of those points has their elevation. So I'll deconstruct those points to find their z value. I can turn that off. I can then do our custom preview, give this geometry a color, and now these colors are filling into there. So it kind of has more of an interesting grid appearance. It's a little more rigid. So that's another technique. And obviously you can change these colors to be whatever. Maybe now it's lava, I don't know. Now it's polluted water. So there you go. So that's the other way in which you can start to kind of represent your height fill. It doesn't have to be a nice smooth transition. This could be a little more rigid so you can see more of a defined point. Looks like we'll get out a little early, but I'll just show you, like, again, I talked about how I like to kind of divide surfaces this way because this is where you can start to do really interesting surface manipulations with these. So let's go ahead and let's say based off of the angle of these, all these different cells. So let me delete this real quick. So based off of whatever the angle that these cells are facing, we can start to manipulate them. So maybe if they start to get really flat, maybe they start to shrink a lot. And then when they're more vertical, they stay their same size. It almost looks like you're reinforcing those edges and then you're allowing the flatter areas to kind of shrink. So what we can do is we'll do the same thing. We're going to find the area. So get all those points. We need to determine the angle of all these cells, which is pretty easy. I'll go to surface, evaluate surface, drag in here, and you can see that's asking for a UV value. We can't use this because it's just a standalone point. If I go back to analysis and do surface closest point, I'll use the point here, drag the surface, and now we have a UV point to drag into here. And this is really just kind of creating a interesting plane for all those cells. It's basically telling us, again, the normal or that direction that they're facing. So now we can say if it has a really steep angle, it could stay the same size versus if it's flatter, it'll shrink. So we're going to compare this direction of all these cells with a vertical direction. So vector, I'm going to go through this kind of quick just because it's kind of a teaser. We'll get into this more of the second half of the semester. So I'm going to compare this angle with the Z angle. I can even change it to degrees so I know what I'm looking at a little better. And we'll go ahead and start to shrink these cells or scale them. So I'll do scale. I'm going to scale all this geometry based off of their center points. And now I have to choose their factor. So now they've just all uniformly scaled half their size, which is kind of boring. It's just still very uniform. Now we want actually these cells that are really vertical to stay the same size, but then when they start to get flatter, they shrink more. So let's go ahead and do that now. I'm going to take my degrees, remap them so it's an easier value to understand. And then I'll use my favorite graph mapper to give it something a little less linear. And I'll use the Bezier one. So essentially, the closer it is to that angle, it's going to be a lower value. So I want it to shrink, but I don't want it to completely disappear. So let's just have it to be like 0.1 scale factor. So it'll be a tenth of its size. And then when it's further away, it'll still shrink, but just not as much. I'll do like 0.90. Hit OK. I'll drag that into there. And this is where you start to have fun again with the parametrics. So you can see where it's flatter, they get really small. If you want it to be more dramatic, you can start to kind of give it a solid, more solid, and then
you could do the gradient on that as well.
Yep, so now you could do the same thing where this could be even easier where you're just, I mean, yeah, you could use the same angle degree. So now, because Aaron's that curious, we'll give them all their own corresponding colors. So let's do, again, we'll just do it based off of that same color degree. We could really actually use the same one. So math, minimum, maximum. We'll go ahead and deconstruct it. And let's give it a more interesting color gradient. Actually, I'll show you something even cooler. So I'm actually going to convert these, because they're surfaces now. And unfortunately, with surfaces, you can't give it a transparency, but you can give a mesh transparency. So I'm actually going to convert these to meshes. And what's great is that it's also asking for, or oops. Let's do then display colors. So instead of them all being pink, let's do, I don't know, just pick, someone pick one color. No, not pink. I don't want to seem like I'm swirling through Pepto-Bismol right now. Orange, all right. So let's do a solid orange. Is that to your liking, Freddie? More on the red side? Like that? All right. All right, so I'm just going to use essentially that's close to that same color. And it really doesn't matter because I'm going to make it really transparent. Because right here, you can see the alpha channel. I'll drop that to, maybe I'll give it slight, still some opaqueness. So you can see even like the gradient changes to this kind of those dashed or those checker marks like in Photoshop when it means there's no pixels. Now I'll drag that into there. You can see if let's change this display setting. Let's change it to white. Let's get rid of this pesky grid. So now you can see that those ones that are really small also are more transparent versus the larger ones have more opaqueness and are larger. Yeah, there you go. So that starts to create something interesting. So if you imagine like if this were like a natural landscape that you wanted to use some kind of erosion prevention measures, you could say like, oh, I'm going to start to align those vertical parts with some kind of reinforced tiling, and then maybe they are something kind of interesting in color. If you want, you could even let's add one more degree. What if you wanted to transition from colors from like over here to the other side? You can use the same thing where you then do, let's do area to find those points. And instead of doing it on the Z direction, we can do it along the X direction. So let's curve or vector, deconstruct. And so now we're going to base it off the X values. So it's going to math, bounds, deconstruct. So instead of it doing it like this, we'll do Oops, I guess I need to go in the other. Oh, right. So it should have been the Y direction. Huh. That was screwed up something, didn't I? Oh, that's. Oh, what? Why? So just for the purposes of. Yeah, now it's kind of like this interesting heat map that fades from a transparent to solid. I don't know. Start to do some pretty fun stuff. So yeah, that's all I have for you guys. Let your mind wander and start having fun.
Very nice, a lot of good stuff there.